Hello, my A-level further math students. Uh, Let us proceed from our previous video where we learned the condition when an object completes the vertical circles. And if you recall that, the condition for an object to complete the vertical circles is u should be greater than or equal to 5gr. Okay, so now here is the first question of this exercise 15C. It says a particle of mass m is attached to the end of a light inelastic string of length 1.5a. So you see that I have shown this length 1.5a and its mass is m, so the weight is mg. Okay, and then it says when the particle is resting in equilibrium, so this is an equilibrium, so I can show that there's a tension T in the string right now. So this T is going to be equal to mg in this situation. So it says it is given a horizontal speed of square root of GA. So here is the initial speed given, square root of GA. If you look at its radius, it is 1.5a. So what do you think that how much should be the initial speed if this has to complete the vertical circles? If you substitute your r over here with 1.5, you see that this has to be 7.5 gr if you just allow me to change this a with the r. So this is just gr over here, the given initial speed. So this is quite clear that this object, this particle, will not be completing the horizontal circles. Okay, if it had to complete the horizontal circles, it had to go like this. Let me show you like this over here. So you see, this is the crucial point over here. This condition is only because if u is more than this, you give a good big initial velocity, only then it can pass this point over here, because at this is the highest level over here. This is the point where your potential energy is going to be the maximum. When your potential energy is maximum, that means the kinetic energy is going to be least. So kinetic energy depends on the velocity. So if you have given a good initial velocity which is more than 5 times the square root of 5 times gr, only then this is going to complete this vertical circle. So in this condition over here, we are sure that this is going to stop this circular motion anywhere before this highest point. Okay, so when this will stop that circular motion, so during that circular motion its v would be 0, where this this string would be slack. Okay, to solve such questions, we should always have an initial situation, initial condition, and then the condition in general while moving in these vertical circles. Okay, so we have to see that what is the sum of the potential and the kinetic energy here initially, and what is the sum of the potential and kinetic energies in general. Okay, initially, at this point we have the potential energy is going to be this is the level from where we're going to determine the potential energy. So right now this is 1.5a below this level. Okay, so the potential energy is going to be minus 1.5 amg. Okay, and generally if you look at this potential energy, so you will have to determine this level over here. This angle is theta. So this length, if you just take this radius as 1.5a, so this is going to be 1.5a cos theta. So generally the potential energy is going to be minus 1.5a mg cos theta. Okay, now let's see what is the kinetic energy initially. The kinetic energy initially is going to be, we have this initial speed given as the square root of GA. So this is going to be half m and then the square of this will give you GA. So this is the kinetic energy, the initial kinetic energy that we have. And in general, the kinetic energy would be half mv square. Now, through the law of conservation of energy, we can say that the sum of the energies initially should be equal to the sum of the energies generally. So this is the equation that we get. This is the sum of the energies initially. This is your potential energy, the kinetic energy. This is your potential energy in general, and this is your kinetic energy in general. Now we are given that like the situation when this object is instantaneously at rest. So like, this object was moving in circles, and suppose it reached up to this, so, and then the string got slack, and this, like, rather than moving, it just, like, moved like this. Okay, so we have to put this v as 0 in this equation. So once you do that, so when you put your v, this v0 here, we are left with this equation. Okay, and now you see that you can cancel out this AMG with the AMG and the minus with the minus. So you have this cos theta that is equal to 1 over 1.5, and this will give you the angle through which the object has turned when this is instantaneously at rest. Okay, now we move to the fourth question. Now we are given the situation is same. This time the object has a mass 2m, so its weight is going to be 2mg. Let me show the weight like this. This is going to be 2mg, and the radius this time, the length of the string is going to be a. Okay, and we have been told that this is given an initial speed of what is that? The square root of 7GA. So guys, if you look at this, whenever you have such situation, you should first of all determine that if this object is going to complete vertical circles or not. So you see that the radius is a, so this is already more than the square root of 5GA. So this means this object will definitely complete the vertical circles. So this would be moving like this, like this. Okay, so this will be moving like this. So now what's the problem? The problem is that we have to find the greatest and the least tension in the string. So guys, see, this is the point where its potential energy is least, and this is the point where its potential energy is maximum. Okay, so when the potential energy is least, so that means the kinetic energy is going to be maximum. Okay, and when the potential energy is the greatest, then there is the that kinetic energy is going to be least. So that means these are the two extreme points over here. So basically we find the greatest and the least tension in the string. Okay, so if you look at this, let me first of all show you its general situation over here. Generally, this particle, when it has rotated at an angle of theta degrees, this is square root of 7GA. Okay, then here is its weight, which is going to be 2mg. This is the tension in the string. That is what we have to find, the greatest and the least tension. And at this moment, its speed is v. So once again, we have to see that what are the energies initially and generally. Okay, so as you know that this is the level from which we determine the height of this object during this vertical circular motion. So that means here the height is minus a. So initially the potential energy is minus 2 a mg, and generally this would be, if like if we determine this level, this is a, the radius is a over here, so this length is going to be, this height is going to be a cos theta, and in fact this is minus a cos theta, so that is why this is going to be minus 2a mg cos theta. Okay, initially we have the kinetic energy, that is half into m, which is 2m, and it is the square root of 7ga, so this is, its square is going to give me 7ga, so this is going to be 7a mg, the kinetic energy initially, and generally the kinetic energy is going to be half m, and this is v square, so which is going to be mv square. Now by using the law of conservation of energy, we have to put the sum of these two energies initially equal to the sum of these two energies generally. So through the conservation of energy principle, we have the sum of the energies initially equal to the sum of the energies in general. Okay, so now we have this one relation where we have v and the theta involved in it, and then we can have the second relation through the F equal to ma principle. You see that here is this tension, this is acting towards the center, and here is the component of weight opposite to it, this is theta, then this is going to be 2 mg cos theta. Okay, so you should allow me to write, yes, so I can write this t minus this 2 mg cos theta, that is equal to mv square over r. So m is basically 2m, this is v square over r, which is a with us. Okay, so this is one relation with us, and this is another relation with us. This is from the conservation of energy, this equation we got, and this is from F equal to ma we got. So we have to manipulate them algebraically to obtain an equation between t and theta, so that we can determine the maximum and the minimum values of this t. Now why do I want an expression and an equation, a relation between t and theta? The thing is that if you look at this, at this level, I have already convinced you guys that these are the extreme cases where we can find the maximum and the minimum tension and strain, okay, because of the maximum and the minimum velocities over this vertical circular motion. Okay, when our object is at this level, theta is 0, okay, and when the object let me call this point A and this is the point B, when the object is at the point B, your theta is going to be 180. So if we have a relation between the t and cos theta thing, so we can put the two different values of theta to determine the two extreme values of this t. So from this rule, I can say that I have mv square, this mv square is equal to, the sum of these two is going to give me 5amg, and this moves to this moves to the other side, so this is going to be plus 2amg cos theta. Guys, inshallah very soon you will see that the improved quality of these videos, because of the lockdown outside, because of this corona disease, all shops, all markets, everything is closed. So I'm just using my mobile phone to make these videos. So inshallah, hopefully the quality of these videos will get better when I have the professional camera with me, inshallah. Okay, so in the meantime, you should excuse me for this quality of the video. I hope you don't mind this. Okay, so now this is the equation, and from this equation I'll take out this mv square from this equation, so that will give me in fact I should make this mv 2 mv square over a. So if I multiply this with 2, okay, so this would be multiplied by 2 and this would be multiplied by 2, and then I divide it by a. This is over a, this is over a, this is over a. So I have this 2 mv square over a, that is equal to 10 mg. I'm holding this in my hand, okay, you see. So I should have a stand for this, or some sort of a tool to hold this camera. Now this is going to be 4 AMG cos theta. Okay, so we can pick this 2 mv square over a's value in this form, and we can substitute over here. So I have this now, t minus 2 mg cos theta is equal to 10 mg plus 4 amg cos theta. So this tension in string is going to be 6 amg cos theta plus 10 mg. Now I'm leaving the rest up to you. You only have to put theta, first of all, 0 for this level, and then you will put theta equal to 180 degrees. So you will get two extreme values of this tension. Okay. Now thank you very much up to this level, and in the next video I'll be covering the next kind of situations where we will be having a hemispherical kind of a surface on which the object would be moving in circular trajectory. Okay, thank you.